Hello and welcome to your first lesson revising moments and talks and couples and whatnot. So I've split the topic up. Today we are going to look at moments and equilibrium, and then tomorrow we'll look at talks and couples and whatnot and bring that on. I think it's tomorrow, next lesson anyway. So let's talk moments first of all. So moments, I've written an unofficial definition here. It's a turning effect of a force, and it's measured in Newton meters. So I remember it. It's obviously not what you can write in an exam, unfortunately. If you are asked for the definition in an exam, try and just write the equation in words, and I've written that underneath. Moment is force times perpendicular distance of the line of action of the force to the axes. It's not a very catchy definition, but it is what you need to know. So m is fx, where x is that perpendicular distance. So I've given two examples here. Finding the perpendicular distance. So the top one is the most simple type of moment question you'll see. You've got a nice distance, a nice force at right angles. You can work out the moment, 10 times 3, 30 Newton meters. However, underneath I've written another example, but this time that force is at an angle of 20 degrees. So you have two options here. In order to calculate the moment, you need the perpendicular distance. So option A is find the perpendicular distance. Now you can use trigonometry to find that. In fact, shall I write on here? Can I write on here? Yes, I can. The perpendicular distance would be that dashed line, which would be 10 sine 20. So pop that into your calculator. 3 times 10 times sine 20, 10.26 Newton meters. Now, don't ask me why, but I always prefer B, which is the other option of finding the component of the force that is perpendicular. So I will find 3 sine 20, which is the kind of component of the force that goes like that. Don't know why that's not drawing, but it's meant to be doing the other side of the arrow. And then times that by the distance. Both of them give you the same answer, so it's really not an issue at all. Okay, and the final thing you need to know is the principle of moments. When a body is in equilibrium, the net force and net moments acting on it is 0. For a body in rotational equilibrium, so that's kind of a way of understanding it, the unofficial definition again, and the bottom one is the official one. So for a body in rotational equilibrium, the sum of the anti-clockwise moments at any point is equal to the sum of the clockwise moments at any point. And you can use that in calculations. Pick a point, say, right, what's the anti-clockwise moments, what's the clockwise moments? They should equal each other. And you can tend to do equations to work out your missing values. Right, that was it, nice and easy. So hopefully that made sense. See you all soon.